Welcome to Echoes of Oddbo, the podcast exploring the strange, the mysterious, and the curious. Let's dive in. Why is the universe so silent? This is the question behind the Fermi Paradox and the ultimate uncertainty surrounding humanity's fate. When we look up at the night sky, covered in stars, vast and impossibly deep, it's hard not to feel a sense of awe. Yet behind this beauty hides a disturbing mystery. Why is the universe so quiet? Why, across billions of stars and countless galaxies, have we never heard a single echo from an alien civilization? This question didn't come from science fiction writers. It came from a real afternoon in the summer of 1950. In the cafeteria of the Los Alamos National Laboratory, physicist Enrico Fermi was casually chatting with colleagues about nuclear physics and space travel. Suddenly, he paused and asked a simple, devastating question. The table fell silent. Everyone knew he wasn't asking about people on Earth. He meant the civilizations that, according to astronomy and probability, should exist throughout the galaxy. From that moment, the question became known as the Fermi Paradox, a crack in our cosmic understanding that exposes a deeper, darker uncertainty underneath. At its core, the paradox is simple. The galaxy should be full of advanced civilizations, yet we've found absolutely nothing. No signals, no structures, no evidence, nothing. And this gap is not philosophical, it's a scientifically grounded problem we can calculate. Picture the galaxy. A massive spiral system roughly 100,000 light-years across, containing up to 400 billion stars. At least 40 billion resemble our Sun, stable, long-lived, and capable of hosting habitable planets. Thanks to the Kepler Space Telescope, TESS, and decades of observation, we know that about 1 in 5 Sun-like stars has at least one planet in the habitable zone. Do the quick math. 40 billion Sun-type stars, divided by 5, gives us roughly 8 billion Earth-like worlds. 8 billion potentially rocky planets with oceans, atmospheres, and all the ingredients needed for life. Even under pessimistic assumptions, only 1 in 10 million Earth-like planets develops life, 1 in 10 million evolves intelligence, and 1 in 10 million becomes technological. Many versions of the Drake equation still suggest something surprising. The Milky Way should have at least dozens of detectable civilizations. Even the most conservative estimates place the number at 1 to 100. Meaning somewhere right now, there ought to be civilizations using radio waves or constructing gigantic structures like Dyson spheres. There should be signs, infrared anomalies, strange radio bursts, altered star systems, something. Yet the universe is silent. And the silence becomes even stranger when we consider time. The Milky Way is 13 billion years old. Humanity has been an industrial civilization for less than 200 years. We've been sending radio signals for just over a century. If another civilization emerged even 1 million years before us, a tiny sliver compared to the age of the galaxy, what would they be capable of? Humans went from steam engines to landing on the moon in 2 centuries. Give us a few thousand years, and interstellar travel becomes possible. Give us tens of thousands, and self-replicating probes could spread across every star. Now imagine a species with a million-year head start. Their technology would be indistinguishable from magic. By now, the galaxy should be filled with their footprints: artificial planets, megastructures, star-spanning networks, signals flooding space. But we see none of it. No signals, no heat signatures, no cosmic engineering. The galaxy looks untouched, like a quiet graveyard. Thus the Fermi Paradox. A universe that should be bustling with activity instead sits in eerie silence. Over 70 years, scientists and philosophers have proposed more than 50 explanations for this silence. Here are 3 of the most influential, each capable of reshaping our understanding of existence. The Great Filter imagines evolution as a staircase filled with deadly traps. Somewhere on the path from chemistry to star-faring civilization sits a step so difficult almost no species passes it. The terrifying question is, where is this filter? If it's behind us, we are incredibly lucky. But if it's ahead of us, then every civilization that reaches our level eventually destroys itself. Nuclear war, climate collapse, AI catastrophe, nanotech disaster, or something unimaginable, a universal trap built into technological evolution. Every species that reaches for the stars may vanish before touching them. Perhaps advanced civilizations already know about us but deliberately keep their distance. Like zookeepers watching animals, they may observe quietly, without interference. Maybe they've been watching since ancient times, waiting for us to mature or self-destruct. If true, Earth might be enclosed in an observational boundary. SETI's silence wouldn't be accidental, it would be intentional. We wouldn't be alone. We would simply be animals in an exhibit. Maybe complex life is unimaginably rare. Earth may be a cosmic anomaly, a perfect convergence of conditions, a stable sun-like star, a perfect orbit, a protective Jupiter, plate tectonics, a magnetic field, and a large moon. If these conditions are 1 in a trillion, then the silent sky isn't a mystery. It's simply the truth. The universe may be vast, yet empty, and consciousness may have ignited only once. The Fermi Paradox is a mirror. It reflects our fragility and the stakes of our moment in history. Whether the great filter is behind us or ahead, whether we're being watched or utterly alone, everything points to one conclusion. We must reach the stars before our mistakes catch up with us. We must build sustainable technology, ethical AI, and global cooperation. Otherwise, the universe will remain silent forever. That afternoon in 1950 still echoes today. Maybe the real answer depends on the choices we make next. Thanks for listening to Oddbo. Stay curious, and see you next time.